So it depends upon which perspective that you have. When you're trying to sell a platform, let's say you want to try and market a platform to a manufacturer, the biggest competitor is their internal team. So if you go talk to a technical team, they say, "Oh, I can build this. This is easy. It'll take me a couple of months, and I'll have this platform ready." And they're in for a huge surprise. So there is quite a bit involved in building a platform like this that is truly scalable. It's got the performance that you need to keep a plant going. The worst thing you want in a manufacturing plant is something goes down because of your data. Right? You can't stop a Tesla factory because somebody messed up their code. Right? That's the worst thing that can happen. If you're in a retailer and that thing doesn't detect somebody walking by, it doesn't stop the world. But if it happens in a manufacturing plant, now you're talking about hundreds of millions of dollars in loss every hour, every day. So it's fairly involved in building a platform like this. I think there's quite a bit of technology that exists today. So I think Personograph has done quite a bit of work with the scaling and the analytics piece. Data collection, especially for real-time data collection, I think needs a little bit of work there. I think GeneCloud has done quite a bit of work with the whole remote algorithm execution. I think there's concepts from ExpressPlay and CSERT that go into device management and essentially verifying that the remote device and the server can communicate without anybody tampering with that information. So that is a critical piece as well. So I think there's quite a few pieces that are already in existence today at Intertrust that we can put together in a platform like this. And I think there's a few pieces that probably need to be developed as well. I don't know if that answers your question, but.
I think it's an ongoing question.
Yeah. I think, and as we develop this, we will learn as we go, exactly. As we develop this, as we start working with applications and customers, we will definitely learn as we go. In my previous company, we actually built a platform for targeting essentially the electronics manufacturing space. So these are fabs that make computer chips and the equipment that goes in those fabs. So each equipment is $2 to $10 million each. A fab probably has about $3-4 billion worth of equipment in it. So what you're trying to do there essentially is optimize the efficiency of that line and make sure it never goes down. Because if a line stops at Samsung making computer memory chips, you're talking about tens of millions of dollars in loss per hour. And that's basically the challenge that they have to face. You had another question, or?
Well, I kind of asked them both at the same time.
So from an adoption perspective, do most manufacturing plants already have edge computing?
Do most? Not necessarily true. So most smart machines have built-in controllers. Okay. But that does not mean it's this concept of edge computing or edge agent. Those are really control boxes. So they're looking at real-time data and making real-time decisions to do whatever they want to do with that computer. They don't have the concept of learning from a much larger data pool and sending that learning down into the edge agent and then doing analytics with it. So that's the whole concept of edge agent, edge computing that comes into play here.
When you're thinking of building this platform, are you thinking about building the whole infrastructure starting from the device to this? As in, like going from the edge agent, software needed on edge agent to the whole end spectrum?
So a typical platform, yes, that would be true. So what we do on the edge agent is you essentially develop an SDK that you give to somebody, and that SDK knows how to communicate back with the platform. That SDK also knows how to authenticate or get authorization from the platform, and then let them build the actual agent software using the SDK on top of it. Yeah.
So when the edge agent actually is, you send the algorithm down or the analysis
Yeah.
down to the edge agent, it actually brings with it the ability to take advantage of all that's gone before.
Yes.
So, and then after that, that analysis is done, what's learned from that analysis is put back into, so the next people that come along take advantage of that. So you sort of get the statistical significance of a large net set of data instead of always operating just on the 50.
Exactly. So maybe not all the results go back. Some of the results do go back, but I mean the platform obviously can run the same algorithm here based on the data as well. But the concept is to be able to run it locally right next to the device, so it's much faster in terms of response time, and you eliminate any potential issues that you may have with connectivity and so on.
Is that as useful as it would be if you actually had all of the raw data to work with?
You would need quite a bit of compute power then on the edge. That becomes
Well,
incredibly
I'm just saying,
expensive.
suppose you could somehow or another work it out so that people would actually give you the data, the raw data to work with. If you could provide strong governance over the data.
I think that really depends on how large the data volume is. And so the bandwidth is still limited for data transfer and everything between the edge and the cloud. So if you have petabytes of data in the cloud, you're not going to send the petabytes of data.
In some circumstances, that's true.
Yeah. So then you only send the analysis capability down. So you're really limiting what goes over the wire down to the edge.
I think in terms of the wind industry where the OEMs, the turbine manufacturers don't want to share their data.
Yes.
But we're not talking about nearly the same amount of data, I don't think.
Yeah. So in that case, yeah, potentially you could have some data transfer. But then if you go back to the silo option, you probably end up with something like that where they keep their own data store. The turbine, the wind farm keeps its own data store, and then they just have an understanding where they can share results with each other. I think that becomes more of a logistical / legal issue than a technical issue.
Yeah, I just wonder if you get as much from being able to take pile analysis together, and then later to work on that analysis as you would, or the same information as you would, if you had all of the data constantly being able to do the analysis on the entire data set.
So normally, at least what we have done in the past, what I've done in the past is you take this large data store, right, and you create algorithms or models using this to learn what a typical behavior should be. Right, so now that model is fairly compressed, and you send that model across the wire to the edge. So now the new data that comes in, you run the new data against that model to see if the predicted behavior of that matches the actual behavior. If it doesn't, you raise an alarm. So that's how you kind of take the learnings and send them back down. Other questions? If you have any questions later on, I mean, I'm in the room right next door in the personograph breakout room, so feel free to stop by, ask me questions. I really can talk about this for hours if you want to. Okay. Thanks.